20 minutes late. Okay, cool. Yeah, so next I'm just trying an idea, but I feel like it's too ambitious. I'm probably going to pull it back some. But it is a cool idea. Most likely I'll have to look up an algorithm written by a professional instead of whatever jank-ass shit I'm trying to do. Alright, let me see what we got. Drop a little message. Okay. And you might see an ad. They run one at 5 minutes. So I'll be doing a little bit of setup. And then I set it to be once an hour. It'll do 3 minutes. So we'll just do a break every hour. I think that's better than like every 25 minutes. Alright, getting set up. Okay. So I got some jank code here. I was working on making the map a little bit easier to understand, and then how to make paths. And I think my idea is too difficult than the regular idea, sort of a hybrid. You can see like right here, I'm just trying to draw a path from here, and that's as far as I get. It should be going like this, but it doesn't. So yeah, we'll have to see. But I think the actual way to do it is pick 2 rooms, set the door for 1 to 0, and then go to the other one, and then just do Dijkstra map descending. And that'll just get you paths real quick. It would have been fun to have it kind of like go randomly like this. But I don't know. I think getting something that you can play is better than something that's amazing, but takes you 10 years to figure out. So, yeah, let me just confirm that this neighbors function is actually working right. Okay, YX, XY. I'm using this pair, but I'm gonna make my own. Make one more struct. It's kind of dumb, but I'm overloading pair, which comes from that algorithm. So I kind of need to rewrite it. There's also just, you know, the vector 2, the classic. Let's do I don't know, we'll just call it point. There we go. For lack of a better word. Just so I can stop being a dumbass and confusing I and J with Y and X. Alright, we'll come up with a better name for that later. And then we're going to look for pair. Yeah, that's fine. And then we're going to come down here. All right, so an ad's going to start soon. Take a little break. I'll get some setup. And then we'll be ready to go. You won't miss much. Back. Let's see how that works. Kind of get the ads out of the way. Now we got a whole hour. Okay, yeah, so I gotta get this. I've been like juggling J and I and X and Y, and I'm not good at either of those, so let's just unify everything. Let's see if this nearest neighbor thing works. I am trying to like do the C++ thing, but God, I hate this. This is so... I mean, I know it's safer, but at the same time, I'm like, my C brain is like, ugh, just use pointers. So we'll see how it goes. I may convert back to pointers. Alright, so let me see what we got. We got that. Also, this needs some serious testing love. I'm just getting one room, like about there, and then I'm just trying to make a single path in one direction. Alright, let's just run that. Oh, you don't have to use a pointer. You just do an index, an integer. That's it. An array of unknown size. In C, that's pretty tough, but you use realloc. Let me show you. It's kind of gnarly, to be honest, but yeah, it's pretty dodgy, but you want to use well, this is the C++ docs, but that should be fine. Yeah. Now in C++, don't do this. Just use the basic vector and do it that way. But yeah, if you do this, okay. So basically, if you need an array, you don't know how big it is, allocate an amount, and then you just have functions that can add to it. And when you run out of space, you reallocate it so it's bigger. But there's a lot of implications to it, because the pointer you get back from this might move. So it's not like it increases the size. It might have to make a new piece of RAM. And I forget if it actually does a full copy or if it does like a special copy, but basically you can't rely on that pointer being the same. So anytime you increase the size, you have to change the pointer. So that's, yeah, that's one weird thing. And I think there's a few other kind of weird implications on it, so read up on that the most. Yeah, so, and remember, I mean, you got shitloads of RAM on your computer. You could just say like, all right, I'm gonna malloc up like a megabyte, and then just go to town and write the code, right? And just keep track of how much you did. If you run out, then abort and say this is too big, right? And if it's too big, then give yourself 2 megabytes. Like 2 megabytes of RAM these days is like nothing. And so then just allocate however many you need, and then when you get it working, it's nice and clean and simple, it's working, then go in and see if you can like make it increase in size and grow. Also, just finding somebody who did it. Yeah. Yeah, that's all you have to do. But there's a couple of strategies too. Another one is pretty much everything you're going to do in C is going to be real gross. If you can find a library that will do it for you, that's what you want. You want to look for a dynamic array. I think the, yeah, something like this. This is basically going to give you the equivalent of the C++ vector. I think this is one. Also that Apache library I mentioned in the book, they have a bunch of this stuff. It's a good little library. It just has like generic crap that you need all the time. Yeah, C vector, null program, what have they got? I think these are pretty good. Arenas, yeah, that's kind of using it. Maybe check this one out. He's showing it in the context of graphics. But if you're looking to do it yourself, you probably want to go read a couple of things about... Oh, drop your link in the Discord chat. I can see it there. So a couple of strategies that you have, you just do realloc and keep track of the size, how much used. Usually it's like a struct like this. Oh, Project Euler. Yeah. So I like the idea of Project Euler, but the implementation always pisses me off. had such a good opportunity to actually teach the math, and instead it's like this cryptic description that only someone who already knows how to solve the problem with math can solve. You mind if I pull it up on... I'm assuming it's okay. Let me know if you don't want to. Yeah, just like grab 2 links. Anyways, I'm familiar with it, yeah. They literally, like, this could have been the greatest math textbook in the entire world, and instead you get multiples of 3 or 5. Look at this crap, man. They could have had so much education here, and it's like a problem description that's designed for their kid that they taught how to do this when the kid was 10. You know. Remember that thing I taught you about? Yeah. Such a missed opportunity. They should have got like every PhD in math they could to sit down and write the very best description of this problem, how to solve it in code with math, how to do it intuitively. This should have been like, under here should have been just an entire Wikipedia on this one problem. And instead what we get is 2 horribly defined, not specified sentences. Just such a waste. Anyway, so usually, and then this is real rough, so like if you can find a library that just does this, just use it. But, or I think I made one in my book, but, so you need size T max, size T, oh, it's off the top of my head. Use, that's how much is used. And then a pointer, it can be a void pointer, but if you know you're just going to be using integers, just use int. And then contents, something like that. And then you need operations like extend, shrink. And if you know you're never going to shrink it, then don't bother with that. Just extend. And then you want to be able to get at used, max, all those things, right? So you need functions to do that. Kind of keep it from leaking out. Then the next thing is when you realloc will return a pointer, and I believe the pointer can move. So you want the functions to always use this pointer. And then every time you realloc, you reassign that pointer. And I'm sure I'm missing a few other things, so if you can't find one, just thrash it. Then the other way to do it is, this is like probably the worst way to do it. Probably the worst way. But you do an array of these, and then you just set them at a fixed size. So you just say something like probably if it's C, you're going to do define. Let's say you want to make it 10K. Put parentheses around that. Okay, so you set your chunk size, and then this is actually going to be, totally get this, I'm like mixing languages, but this is going to be a list of arrays of that size. And then what you do is you fill them, and then you just have to calculate whenever someone wants something that's, let's say they want something that's at 10K plus 1. You have to calculate and go, oh, that's actually in this chunk here. Or you can actually have the contents be a linked list. So linked list of chunks. And so then you have to calculate, okay, they want here, and then you go skip through the list, you find that chunk, and you return it. So that way is gnarly, but it is going to be generally faster. You have no copying when you do that. But like I said, I wouldn't even bother. Just make a gigantic array. Just use malloc to make yourself not what you're doing, like that's going to do it on the stack. Just use malloc to make a 2 megabyte array. That's it. Yeah, I wouldn't even bother, because it's so much, the more important thing is to get it to work, right? In the simplest way you possibly can. Then you optimize it. that's when you get into, okay, if I use a dynamic array, I can do it this way. I can shrink it to size. There's also something to be said for like, you allocate a chunk of RAM once, right? Like you just allocate 2 megs, keep track of how much you use, like do the work, and then reallocate one time to shrink it down, right? So then your RAM is just like up and down once. And then finally, if this is something that you just like run once, like as a command line tool or whatever, and doesn't run for very long, it's not like a web server, allocating up like 2 megabytes or like whatever the max RAM you think you need, that's totally fine. If it was a web server though, and you're like, oh, I think I'm going to need 2 megabytes per web connection, that won't work for very long because that has to run and handle lots of connections. So yeah, that's what I recommend. Okay, now I need to tackle my own Project Euler. Y, X, Y, X. X, Y, X, Y. Awesome. Okay, so now I think I will be able to keep my head more straight about this. And neighbors. This is probably not the best way to do the neighbors, but yeah, we're just going to keep it like this for a bit. And honestly, just super duper hate this. Alright, so let's run it and just see if it actually does what I want it to do. I think it's not compiling. Yeah, okay. Okay, so I think we're getting closer. It's finding this one, I think. No, this one. There it is. Okay. Yeah, so it goes 1 block and then stops. So you can see I have this dot. Okay, so we can go 1 and then it stops. Alright, let's take a look. Okay, it goes there. Alright, gotta do the logging now. So this will reposition us at that point. And as long as these are up, we find out. Okay, let's look at those are both, that's good, greater than 0. And then didn't find anything. Okay. So now we got to come up here and look. Oh, also, I may be initializing these wrong. Nope, that's good. Actually, now that I've fixed that, I can just go ahead and do out.y, out.x. XY, XY, gotta reverse it for this coordinate though. And X is 0, Y is 1. Yep. We pre-calculate it there. This will update that because it's an out parameter and return true. Okay, so we just need to know okay, let's try that. If I could spell. All right. Now I have points. I don't need to do this dumb double array shit. I can just do... Yeah. Okay, this is gonna make things so much easier. I should have done this like before I started the stream. Alright, so this is... Just need 4 points to get the like top, right, left, like that. And that dimension, I think, is going to be wrong. Let me just check. I think I get rid of this. That'll make it individual points each. And then... Yeah. And then pointer. Way easier. Nope, it's gotta be Y and X. Those are wrong. Okay, let's review. Alright, so, yep, that's Y. This is XY, XY. That's our list of points, or an array of points. So we have that. We get the dir. It's this. Okay. We will get something, I hope. Oh. Oh. I got a format that's wrong. There's another one of these irritating... Apparently you just keep adding curly braces until it works. Oop. Right, so all we're trying to do is kind of get a line going in one direction, basically. That didn't seem to actually make a map I could work with. There we go. Okay. Oh, I'm not using the door, am I? There's the door. Door X, door Y. Yeah, that's right. See, if it's a -999, that means it's at a location is X 16. It's not that one, it's probably this one. You know what? I'm gonna make a smaller map. It's too hard to figure out from the giant map. Yeah, I don't need to make a massive map. Just make one that's like 25 by 25. By 20. Over here counting cells like an idiot. And we need to put more protections of where stuff is at. try. Okay. Oh, I wonder, oh yeah, this is what's going on. No, so this map is inverted. What this is the rooms are here. So I'll explain it to you. So it's kind of a dumb idea. We'll see if it actually works, but the purpose of the Dijkstra map, these numbers, is to give you a path, right? So normally it'd be like, let's say there's a monster here, and the character's here. So all you have to do is just move to a square that's a lower value. So you would just go 7, 6, 6, 5, 5, 4, 4, 3, 3, 2, 2, 1, like that, until you get to it, right? So I sort of had this idea, if I invert the map, so this is normally our room, flip it, so this is wall, run the Dijkstra map on it, but then set every door to 0, which is how you tell the algorithm these are important spots to path to. Then what we have is numbers that if I go from this door, I go up, I go 1, 2, 3, 4, 5, and then when I'm here, now I go down 4, 3, 2, 1, 0, and I'm at the door. So it's inverting it. We're basically trying to tunnel through the walls, and I've turned the walls into empty space, and then I'm having the Dijkstra map figure out the paths. But the problem is, having it do this for multiple doors is a lot harder than just doing it 2 doors at a time. Because normally what would happen is, let's say the target is this door, and I want to start from that door. I run the Dijkstra map once with this not set and this one set, and then I just walk to it. And then do it again and again and again, right? So that's what my next plan is. But none of that is going to work until I can actually even just walk. Until I'm able to just actually make a path. It's not going to work. Now, the reason why this is turning into 99999 is because, like an idiot, I am setting this here. Yeah. Okay, cool. Yeah, so you can do stuff like that where I can say, like, you can also check that there is a path for the player. So let's say I want to make sure that the player starts here and then the door is here. And then what you do is turn these back into space with the thing. You run the Dijkstra map and then you just basically walk it until you get to here. Right? Just keep walking lower and lower numbers until you get to there. If you never get to it, then you know you don't have a path to the door. You have to run it some more. Okay, I'm just going to walk it. I'm not going to actually make the door, and we'll see how that works. Yeah, it's a cool algorithm. And actually, like this, I'm going to do this as a little game. I'm like, this is a really good way to learn a whole ton of really good algorithms. Okay, so this is more what we want. Okay, so because I keep setting that path, it's wrong. Okay, we found one. 8, 7, 6, 5. Yeah, that's what we want. And then it ends because it can't go any lower. Yeah, so this becomes the end of it. And then we should have a cell that goes down. So then you would turn, you would pick one of the paths that goes down. But it's real tricky because, like, I'd have to pick a path that's not where I just came from. I'm pretty sure there's an algorithm that I'm just, like, too dumb to know. Like you do linear algebra, and then suddenly there's paths everywhere. Okay, so then I got to figure out why. Let me do this. What was I doing? Let's do m walls equals 1. Okay. And then if I run make paths again, that should redraw it, but treat those new spots as walls. But I'm pretty sure it's going to be easier to just pick pairs of rooms, run the Dijkstra map, and draw, and then done. Also, I gotta make sure it doesn't keep trying to go past shit. Yeah, so see? Okay. There we go. That's our first walk. Right there. Okay, we got a path, but I mean, it's kind of garbage. Because we're going to run into all kinds of situations where we try to walk. Like I'm trying to find one. Yeah, so let's say I go here, right? I go this one, this one, this one, right? This one, this one, this one. That makes sense. Okay, so now I'm at this. And I have to go down. But if this was a 3, if that cell right there was a 3, if this here was a 3, going down, I might accidentally go back. So I'd have to keep track of what direction I just came from. However, if I just back up, pick two rooms, and Dijkstra map them, then walk, it'll never go down. I'll always be able to get to it. Turn it into the walls, run the Dijkstra map again, and then so on and so forth, and we should get paths that won't intersect with walls. Then when you're done, invert it, and you've got yourself your map. Let's run it a couple more times. It crashes because I'm not doing any safety of keeping it out. Yeah, so see? That's kind of what we want. But of course it bombs because it can't, I don't have it going any further. Yeah, and then I'd have to make sure that I'm also following paths that are like this. Okay, so. Alright, so that idea is possible, but I need to reformulate it to just do pairs of rooms and instead of trying to do paths throughout the whole map. Unless I can find some slick, fancy algorithm that makes that work. Maybe you find clues on Project Euler. Alright, well let's pick 2 rooms. Let's not do that. We're going to pick 2 rooms. We're going to make paths after. Let's do rooms 3 and 2. Okay, we're going to pick 2 rooms. Then we pick 2 rooms. We're going to run the Dijkstra map and walk 1 time and see what we get. That's fine. Good, but in place rooms, we don't want to do that. Okay, we're going to add a quick little function. Probably just inline that. Alright, so this will change up quite a lot to be a bit like more random about it. And then here, okay, we want to get a room. Okay, we're going to do room 0 and room 1. Oh no, let's go source, and this one is target. We need to only update the map. Okay. This is pretty jank, but we're just trying to test the idea. Alright, so when we set... Okay, we get a room. So we're going to go from the source to the target. The target should have that. Okay. And then the source should not have a spot. Okay, so what this will do is, if we look back at this, what we're trying to do is we pick 2 rooms. We're going to put a door and set it to 0. And put a door, but don't set it to 0. We're going to run the Dijkstra map, go to this location, and then follow the numbers until we get to that door. So that's the idea. Yeah, so this one will be the source. That's where we're going to go from. And this is the target. That's where it's to. So it has the 0. Okay. Okay. All right. If it crashes, it's just because I picked a room that doesn't fit in the map. We'll run it again. This is hack style here. Trying the idea. Oh, nice. What kind of capture card did you get? Always remember, the most important thing in videos is audio quality. It's one of the reasons why I've been blocked for so long. My audio quality just has suffered for like 4 years. All right, so we're going to... All right, so now we make the paths. All right. We're going to go point start is source.door x and source.door y. All right, we're going to go start. Oh yeah, those $20, they do like 1080p. I would run, if you're going to do it live, just run 720p through those. But if you can do it, if you're just going to pre-record, it's fine to do 1080p. Right, so we're going to start and start. And we actually want to go the opposite of what I'm currently doing. Now, actually, we should call this out. It's not really the start, because we're kind of walking it. Right, so go out, out, out. Okay, now we got to go back to neighbors. And we need to know, okay, so that's our directions. Up, down, left, right. And we need to know if the difference is 1, but we can do it this way because we want to go up. So we just want to go any direction where it's a positive. Because if we're currently at like 8, and then the nearest one to us is 7, then that's the direction we gotta go. But I suspect there's gonna be situations where it's not necessarily, yeah, it shouldn't be is greater than 0. No, let's keep it at 1. Yeah, keep it at 1, and then we'll see what happens. Okay. All right, so our path thing, we find our neighbors. We found there. Neighbors out. Okay, let's do it. Of course not. All right, let's get our errors into our editor. Eh? Oh, yeah. Nah, you know what I'm gonna do? I'm gonna be real low class with this. And the target. Okay. You know, all you need for streaming is 1080p. Or even recording, really you just need 1080p is good enough. That's what I do. Most people on their phones wouldn't even notice, and a lot of people watch on their phones. Okay. All right, did we do it? Oh, yeah, because we need to be able to do... Yeah, it's there and there. Oh, yeah, because see how there's like a bunch of similar numbers? So if it's 0 or 1. Okay. Yeah, promising. It's not quite accurate, but... yeah. If, let's just constrain it to here and see what we get. Hey, Caden, how you doing, man? Working on my little game. Alright, well that runs forever. That's always a good one. Am I calculating this difference right? Yeah, let me put that back. Hold on. I think I'm getting this wrong. Yeah, doing good. Just kind of getting in my programming time. I really like C++. It reminds me of when I was a teenager. Right, I gotta think about this. So if I'm like... okay, there's 0. Okay, so if I'm there, that's 0. This is 1. 0 minus 1 is a negative number. No, but I should be more like here. Yeah, so that's 9, 8, 7. I guess you would technically take the... yeah, if you do 0... until you reach the coordinates. That should work. Okay, yeah, just if it's 1 or 0, then we can do it. It's 1 or 0, and then As long as those are greater than that. Let's just throw in if out.y if found, no, out.x equals target.x and out.y equals target.y. Then we break. This is some jank. Some ultra jank. Oh, that's just random. That's just random. I suppose I could just put it there. Actually, wait. Why is that showing up? I thought I got rid of that. Wait. That's not supposed to be there. Oh, yeah. Okay, we gotta get rid of that. I mean, I could just put it there. Alright, so there we go. Okay, let's try that. So basically, we just keep walking until we actually hit the target. Yeah, see, it doesn't ever actually hit the target. Alright, so we're going to throw in a little count. And we're just going to abort if... This is why you don't really want to use while loops, but it's kind of the only way I can think about this. Yeah, that'll work for now. Alright, so it just went 10. Let's see what we got. Okay, I found a neighbor there. Alright, do we got a path? Kinda. Yeah, I think we want to prioritize if it's a lower number, do it. Otherwise, yeah, okay, so here. What we want to do is, if it's 1, and then, else, if difference is 0, Yeah, it's getting real jank. You know, it's interesting because I need to do this to figure out how to make a enemy walk, right? It turns out to be really hard. But it should always go down by 1. So what we want is, we'll go through all 4. If we find one that's a number 1, it's only 1 difference, we go down it. If we find a 0, that means it's just like a sequence, so we follow that. Look at that map again. Yeah, so basically what we want is, if we're here, we can go 9. Yeah, so 9, 8. We could do all 8s. And then all 8. Hmm. Yeah. This is pretty difficult. Yeah. I require a bit of research. But you know what'll happen is I'll be like, alright, I give up tonight. I'll see you tomorrow. And then I'll wake up at 4 a.m. Total solution in my head. Yeah, that's one of the reasons why I take a lot of breaks. Yeah, look at that. That's close. It's just like it's off by 1, though. There's 0. Yeah, it's much more sophisticated than just like find a point and go, right? That's kind of what we want. This is probably like 9, 8, 7, 6, 5, 4, 3, 2, out to there. So I need to be able to go 2, 1, 0, 0, and then stop. Okay, so let's make this not bomb after 10. Let's go, we're gonna give about 20. I just want to be able to see a log. We'll get rid of that once it's solid. Yeah, it is. It's like a mine's bit. Yeah, basically it is. You also need better protections about stuff, all that. Alright, that one worked. Alright, so that looks like it goes. I think this is not getting set. Where is the door? Are we basically going the wrong way? I'll run that again. Oh. It's close. Oh, I'm being an idiot. Okay, we got rid of that. We're recalculating the paths, and I'm trying to make sure that the paths are right. Yeah, that's the thing. I'm not sure. I'm definitely not understanding the algorithm correctly. Also, I gotta... Come on, dude. I'm trying to half-ass this and causing myself more trouble than it's worth. Alright, this is getting dumb. Also, one other thing I gotta fix, or figure out how to fix, is when I have exceptions, normally what I would do is go look at back traces, but I don't have any. Yeah, let's mark it differently. Let's mark as 0. Just so we can see it in the map. Yeah, that ain't working at all. Alright, I'm wrong. We gotta bring this back. Okay, we gotta make sure... Let's mark this. Alright, that's getting done. We're going to stop doing that. Let me see what we got. Let's put the doors in a different place. Door X is going to be... So that'll put it on the bottom right corner, 1 over. Dude, you cannot win. I should be able to go 1, 2. We're doing fuck debugging. Until I can figure out how to get GDB to give me a damn backtrace. Going JavaScript style. Back in the day, JavaScript had like 0 debugging. So you would just do a bunch of prints. Yeah, so this first one. So why the hell are you all fucked up? What is wrong with target's door? Yeah, so most likely I've got to clean up exactly how I'm doing that. We're going to get an ad in a few minutes. It'll be 3 minutes and then we have a whole hour. All right, so I gotta get better at where the things are at. Yeah. Also, I gotta sort out why GDB is just completely stupid about backtraces. Just try it out. Get rid of our stupid debug there. Yeah, so what happens is the rooms will be on an edge, and I'll pick a door. The door will just basically overlap. Alright, break time. And we're back. Okay. I need something that checks and make sure that a coordinate is in the map. Oh, don't need to inline it. Just do this. put this ahead of that. And we're not doing this anymore. Okay, we're gonna have if actually, you don't need a point. I just need to know X and Y. Yeah. Damn it. Yeah, it's gotta be a member function. Actually, let's do not. Then we do that. And then we can, I think I'll abort, but yeah, so basically if we make a door, it doesn't work. We need a way to just basically try different parts, like move the door around until it's on the right spot. So this is going to be ultra gross, but let's just say we're going to do that. Like this. Let's say that would make it, let's put it on the top. Let's see if the door can go on the top. So say X, that'll make the top corner. And Y. -1. Okay, cool. So that'll say if it's not in the map, we're going to try to move it to the top. So that gives us a probability that we have it. But we can just keep moving the door over and over again. Yeah, and then at some point we want to be able to say like, oh, and then the other thing I was going to do to make this possibly work a bit better is, where's make room? Yeah. I can shrink this down some. I think I'm doing it when I call. Yeah. So I think we can do this. That'll shrink it down by 1. Alright, we'll see if we can do this. And then I'm going to see if I can make GDB actually catch. Wow, dude. Was not declared in the scope. Oh, yeah. Have to do that. Okay. You know, I think the biggest revolution in wow, hey, that's a good error message. Oh. That's the mistake. What the hell would that wouldn't parse. Interesting. So that's the mistake that made like a whole bunch of OpenSSL bugs are basically this. Where someone had that there, they deleted it and then accidentally one of these lines runs, but they think it's going to do a full if statement. So now there's an now there's an error message. That if statement doesn't do what you think it does. Well, now I can bring that back. But we'll just do that. We'll just do that for now. Alright, we might have some success. Alright, it builds. So now it should be, the rooms are a little smaller, so we have room to kind of draw a door. And also the, it'll check if it's in the map. And if it is, then it'll just try another spot. So eventually I'll probably rewrite this to, like try a bunch of random spots on the room for where the door should go. But also I should kind of rewrite the rooms so that there's basically a notch. If I can get this to run, I'll show you. Yeah. So part of the issue is that I'm putting the door like here, but the door really needs to be a notch. So I need to have, when I draw the door, I need to have the algorithm that draws the room add a notch and set that to 0 and then do the algorithm. Alright, so why did it do that? That's weird. Okay, but let's see if it runs a bit more reliably. Yeah, that's getting better. Not quite, but close enough. Alright, so now let me run GDB. Alright, and we want to catch, throw. What was that crap I was reading? Okay, and then run. Okay. And then BT. See, this is a bunch of bullshit. What is the point of having exceptions if they don't actually bomb out? Am I like being a dumbass and then, no, I'm not. Especially not catching it so I can see where those end up. Okay, what was the other way that Stack Overflow said? Set a breakpoint on this. Okay. You've got to be shitting me, dude. This is irritating as hell. Is it just like a Windows thing where apparently it like fires up a billion threads to run your programs and then GDB is like, I got no idea where your code's at, bro. It's gone. Well, when people ask why do you do print debugging, this is why, because debuggers kind of blow. There should be no situation where I can't set a breakpoint on a stack trace, on a. Okay, let's try this one. Huh. That doesn't seem like it's gonna work. Yeah, super don't get it, dude. It's totally because this is being run with like a billion threads. Let me just look it up one more time. Is it like some stupid optimization crap? Alright, well that means Mason is probably compiling it with all kinds of optimizations which are making it go away, or threads are firing off, so I'll do that offline. But in theory, that should not happen. If I have written this correctly, it should be that if there's a bomb out like that, okay, there we go. Yeah, so it's putting the door like in a random spot, like the middle of nowhere. Take a look. Okay, yeah, it looks like it's trying to go from here and just not getting there. Huh, interesting. Let's get rid of this last make paths. Yeah, I think this idea could work, but I think the other way that you do it with binary space partitioning is easier. I was thinking, you know, you just run it, you just walk. And now I'm like, it's a real pain in the ass. It also never seems to find the target, which just seems sort of like unintuitive to me, right? So it kind of makes me question how this is going to work with enemies. But these are 10s and 11s. I keep thinking these are 1. Okay, no, it should work. So if I set the door here, yeah, it should work. Okay. And also, yeah, if we go down by 1, we do that. Let's look at this. Door Y13, X is 17. So it's like about here. It's this one. So the target is in the wrong place. Basically, the target should be up there. Alright, so I got the target in the wrong spot. That's probably the first problem. Oh yeah, I gotta remember that it's Y and then X. No, that should be correct. Okay, so this is the first problem. Y and X, that's fine. Alright, let's run this again. So we see the update. I think I'm going to do one more thing, actually. Let's not do this. And actually, let's go into main. Let's look at the draw function. Let me see, result. Let's get the walls. Yeah, so see, I'm kind of doing it there. No, okay, yeah, so we can just do or. Okay, cool. So that will put a dot on the path. And then... yeah, alright, so we're going to find it. It does seem to be putting the target location, or the target in the wrong place. So this should be set to 0 on the input map. Okay. So then now we should be able to see what it thinks the path is. I'm already doing that. Stupid. I should actually get it here. Am I using the input map anywhere? Yeah, let's get that every time. I'm not even using it. Hold up. Yeah, let's get rid of that. Okay, yeah, it's putting that there. I don't know why it's putting it there. I gotta have these backwards. Yeah, it's gotta be like this is going backwards. Alright, let's check add door. Alright, let's just get rid of this. It'll crash, but only every once in a while, I hope. Because I moved all the rooms in a little smaller. Crashes right away. Every time. So stupid. Hey, how's it going? Doing my late night session. How's your stuff going? I'm trying to make C++ do math for me that I can't do. I think what's kind of irritating me is that I move these damn rooms around. So I need to have like a better way of making rooms. Yeah, it's like every single one. And then because I can't get a backtrace off of this, it's just like an absolute nightmare. Oh, nice. Cool. Yeah, VR gaming. Awesome. Cool. Let me see. Oh, I know what's going on. Okay, this needs to not be like this. Oh no, that's right. Yeah, I'm being a dumbass. As usual. See, I'm thinking I'm shrinking the room in, right? But I'm not actually changing the size of the room. I'm just drawing it smaller. So then I'm using the original dimension of the room. I need to make the room smaller. Okay. Yeah, so that's a bit closer. All right, we're gonna go, and what did that say? Yeah, so if the door is 0, it should work. But then when I go to search around it, a door of 0 doesn't work. So what I need to do is move everything in, so... Okay, so we're gonna actually shrink the rooms down. So then when we put the damn doors on them, they actually are on the actual new size. And you know what? We're also gonna do this. We're just gonna go... We're gonna do that, because I think I'm gonna have to keep changing the size. So that's gonna move it in by 1, and shrink down by 2. Do I need to do 2 or 1? We'll see what happens. Okay, I think we're getting a little bit better on that. Alright, didn't crash. It's finding some neighbors. Let's see, where is door 12? Door is at here. Aha, we got the door. Look at that, we got a damn door. Okay. And then we're going to try to get to it from 1, 4. So 0, 1. Let's move this in. 0, 1, 2, 3, 4. Right. I need to write out the source location. Okay, so it's going to be right here, I guess. So X is 1. Yeah, so it kind of bounced around here. Let's run that again. It's almost connected to a room. Yeah, so there's issues with the way I'm making the doors and with the way I'm trying to add the door onto the room. And this shit is just fucking irritating. So I gotta look at how Mason's compiling this, because if I'm not able to get a goddamn backtrace, it's going to be difficult to sort of like squash how I'm stepping out of the bounds. Alright, so there's the door. Yeah, so that should shrink it in by 2 cells. I'm not sure why it doesn't. Bring it in even more. Make it small. Alright, so that's what we gotta do. Alright, we got a door here. It looks like it started there and went there and tried to come down. Okay, we got something. No, but it walks a shitload. So this was saying it was going 1, 1 first. 1, 1. That should be that. Okay. And where'd you go after that? And then 2, 1. X is 2. So that's this one. And then... yeah. Yeah, so it's kind of bouncing back and forth. 2, 1, 1, 1, 2, 1, 1, 1. Okay, okay. So I think my method for finding neighbors is just not very good. So that's how you find the neighbors. I think I have to go through and get all the neighbors and then pick the direction that's the lowest. But let me get rid of this. That'll at least keep it from bouncing around, but it'll also stall out because there's all sorts of spots where yeah, so see how these are all like ones? So without a way to have it follow a path. Yeah, this is like real tough. So yeah, this is the kind of thing you're going to run into. Well, no, those aren't actually ones though. That's interesting. Those are not ones. These are like 9, 10, 11, 12, 13, 14. Yeah. Okay. Okay, I found it. Let's take a look super quick. Alright, so target door is at 114. Okay, and then we found a neighbor at 6 and Y is 1. Oh, hey, no, actually, that may be the first success. Okay, getting closer. It's just not going to work this was probably lucky. If I had picked this one, no, it would work, because remember, these are not ones. These are not ones. These are like, probably like 13, 12, 11, 10, and so on. So yeah, so that's going to go from there to there. Okay, let's run it a couple times. It crashes like a motherfucker, but that's fine. It's a start. Yeah, so this one, it couldn't find a path. Yeah, so the target door is there. I need to get the source door on. Okay. You can't handle the salsa you made? I could eat like the most insane spice you've ever had. Like I'm like, spice for me is like nothing. I don't know what it is. I also have this really weird reaction to like physical, like severe physical pain, where I just start giggling. So I used to go to yoga classes, and I'd be in there stretching in a yoga class. I'd be going like a weirdo, man. Like, it's not like a normal healthy laugh. It's like a serial killer laugh. And everybody just looking at me like, who the fuck is this dude? Why is he in our yoga class? Are we all gonna die? Actually, I was looking at some of the stuff that they eat on Hot Ones, and I'm like, that ain't shit. I've had that. I've had like, I can actually, there's that one that's like a million Scovilles. Not the Hot One chip. That one chip, I think that would do me in. But I have like a bottle of, I think it's called Death's Anus or something like that. It's like fucking awful. And yeah, habaneros, I can eat them. I mean, they're spicy. They hurt, but like it doesn't bother me like other people. Okay, so we got some basic paths working. It's gnarly, but that's kind of what we want. And go there, and then go here. Yeah. So if we can just figure out how to do the pairs, then we've got something. But it wasn't really going to work if we were doing yeah, and then a lot of times it just sort of like craps out. So if it starts here, let me look at what the source was. 1, x is 2. So 1, so y is 1, x is 2. Yeah, so in this case, so this is where it works if there's just a descending, 9 through 8. But if you have to go down any sort of like the same, then it doesn't work, right? So if I have to go from 9 to 9 to get to the path, then that's where this fails. So that's going to involve that. That's really interesting because it like significantly overcomplicates it. See, when you're like this, if the difference is 1, then that's less. So you just go. But now you have to actually look at all of the neighbors, collect them all up, and then you pick the one that is either 1 or 0. Yeah. Way more complicated. Florida neighbors. Florida man, or are you talking about the hurricane? All right, let me catch up on some chat. Let me see. Yeah, Yakov, you got a game. what was the name you picked? Let me see. Steel Wolf Studios. Okay. Have you done a trademark search for that? I wouldn't do anything until you get a trademark lawyer to hook you up. You know how to search for trademarks, right? Also, my advice on trademarks. I had to register one and it was a disaster. The dude milked me for like tons of money because he didn't explain the process. All right, so you go to the patent office. Do yourself a patent search. Looking for the thing, right? So I'm going to look for Zed Shaw Hot Ones. Okay. All right, you find there's nothing. So just do a basic search. Search for a trademark. Do that, right? Okay, now, you know it's not taken. Go make yourself a website. And then start selling something. Just put anything on there and get like somebody to buy it for like $3. Okay? Because you can't, I couldn't file my patent, I mean not my patent, my trademark, until I had actually been doing business with that name on a website, which is stupid because, well, then you put your name out there and then you're doing business and then someone else can say, oh, I'm going to register before you, right? It should be you can register your trademark and then go do business. So go make a website, get yourself some logos, do that stuff, but don't spend a lot because maybe the patent's not there. If you got a patent attorney, say, hey, I'm thinking about doing this. Can you do a quick patent search? They shouldn't charge you very much. Then go make your website, put anything up, sell it real quick. That means technically you've been doing business with it. You have a logo, a presence, all that stuff. Then get someone to register your trademark. Yeah, do that. Just put the TM on it. But when you go to register for it, do it after you've been doing some business. Because I didn't do that, and then I had to scramble to craft this whole product and start trying to sell it. And it was just like mountains of time. The dude like ended up bilking me for about like another $600, $700. But if you have your business already and you've sold like anything, just a little bit, you got your business up there, you've been doing like, do a Twitter account, just prove that you've existed for a little while. Then when you go to register, it's very simple, very straightforward. So that's my advice on patents or trademarks. And it's kind of dumb. It's sort of like, well, they want you to have a business already. They don't want people to just like register junk names. But at the same time, I'm kind of like, well, I want to register the trademark. I shouldn't have to be already selling stuff. I should just have like my logo, my idea, register a trademark, done. But that's not true. Okay, so this like barely works. Like barely. Yeah, so see in this case, it's this one. Yeah, probably it's like this guy. And in order to do it, no, that would work. So most like it's this one. Yeah, so you'd have to go, these are probably all the same numbers. And so it can't go any direction. Okay, so you need to be able to allow it to go, if it can't find any that are 1, then it needs to go a direction that's 0. Yeah, it's kind of interesting. I may have to look at how somebody else uses the algorithm to follow the Dijkstra paths, because I hadn't considered if you need to. Yeah, because if you don't, then it's going to go back and forth like it was going before. Let me just try something. did that before, but I think I didn't really have anything working, so. Yeah, that's not going to work either. It most likely started here. And the 0 is going to win out. Yeah, you pretty much have to go here and then look at all the neighbors and then pick. You pick 1. If there's nothing that's 1, you pick 0. And you keep doing that. So how can I kind of make that work? Well, you know, in a way I could say that's a good run for the night. And then I'll just go sleep and then I'll be like at 4 a.m. I'll wake up. It's exactly what happened last night. It was stupid. Yeah, so see, in this case, it totally works, right? Now, so then the process is, I made these rooms tiny small so that I don't have to deal with, like, is it in the map or not? But now the process is, so I pick the 2 rooms and I connect them. First, I gotta get better at placing the doors, right? So place them at more random locations. I pick 2 rooms, I do Dijkstra, pick 2 more rooms, do Dijkstra, 2 more rooms, do Dijkstra, 2 more rooms, Dijkstra. And then it should just sort of make a map that's connected. And then what I can probably do is invert it one more time, and I'll have like a start point and an end point. And then I'll run a Dijkstra map on the real thing, and if I can't get from start point to end point, then connect 2 more rooms. Do it again and connect 2 more rooms. Now, it would have been cool if I could make it be a little bit more random, but I'm not really sure how to do like a random walk. I literally have not done that for real. And last time I sort of did it was probably like 25 years ago. So it'd be really cool if it was like, you know, it was like ding, 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 but it eventually got to the door. Okay. Let me just see if I can sort out like a janky way to do this. Let's say we're going to do size T. Okay, so if we find 1, we do it. Else if diff equals 0, then we set 0i to I. Alright, so now the whole loop runs. This all runs. Doesn't find anything, but I've found one of them that's I. Then when I get here, I go if Yeah, hold up. Let's make this int, and let's set it to -1. Okay. So now, I get here, if 0i doesn't equal -1, then that's what I use to get at... Yeah, then I do this. Because it got set. So I found one square that was at least a 0. Otherwise, I return false because I didn't find anything. Okay. That's just so gross. But don't worry. This is how I work. Yeah. I can explain in a second. Let me make it actually run. I'll show you. Yeah. This is already just a nasty pile of disgusting code, so let's just pile this shit on high. Right, I think that actually worked. Holy shit. Yeah, that seemed to work. Kind of went in a weird place, but that's because I put the doors outside. Once I get the doors inside, it'll be a bit more consistent. But no, that's kind of cool. Okay. Alright, so that's more or less the solution. And I think that gets more complicated, right? Because we pick the best possible square, but then we also want to start doing things like favor the same direction, or even favor a random direction. Alright, so Yakov, what this is a Dijkstra map. So people who make the roguelikes, they use Dijkstra's algorithm for finding shortest paths. What you do is, I say like, I think this was probably the target, and then this is the source, right? Let me think. Yeah. So see how this is surrounded by 1s and 0s? So you set the target to 0, and then you run Dijkstra's algorithm, and it very quickly, I think it's a linear time, puts a bunch of increasing numbers going from the source, right? And you don't have to tell it where the source is or anything. You just give it like 2 matrices and it's done. And so this is sort of like a distance from any point to that. So if I start here, to move to that point there, let me switch colors. I just go 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and I hit them. These ones, these are actually like 16, 17, 18. These are like very large numbers that are 2 digits. So if I was out here, it might be something like this, like that, like this, 7, 8, 5, 7, 8, 5, 5, 5, and then all the way to there. So as long as you keep going in a direction that is like lower numbers or the same number, you'll eventually get to the target. And so what it's used for in a roguelike is if the player is here, switch color again, let's say the player is in this room and a bad guy is in this room. You run the Dijkstra map and the player moves here, bad guy moves here. Player moves here, bad guy moves here. Player moves here, bad guy moves here. Because the Dijkstra map, they're just, every time you move, you recalculate it, and then the enemy will move 1 step closer to you, right? Yeah, well, so that's the part that you have to work on making it kind of random, right? In this case, I'm kind of keeping it dumb simple because I can't make it fancy. But let me show you. Yeah, so in the roguelikes, usually the enemies just kind of go straight towards you, and because you move each time, it looks more random, right? So if you go here, but then the enemy will like move towards you, but then you move here, and then the enemy might do this. Then you move here, they might move back to there because that's the shortest. And you move up there, then the enemy might move down, and so on. So it ends up seeming random, right? But it's just a very simple pathing algorithm. So what I did is I want to draw paths that are not like straight lines between my rooms. So I inverted the matrix. So normally the Dijkstra algorithm would only work in these areas. These are like empty rooms. And this out here is all wall. So what I did is I inverted it. I made this empty and the rooms are wall. And then I set this as a target and this as a source, and I tell the Dijkstra algorithm to go, and then I just walked and I basically tunneled a walkway to there. So that's what I'm going to do. I'm going to take each of the rooms, give them a door, target, draw, and just do the Dijkstra algorithm. Now you don't have to do this. When you do the binary space partitioning, which is like I do this, and I cut like that, and then I cut like this, and I cut like this, and I put a room here, right? And I put a room here, and I put a room here, and I put a room like here, and I put a room like that, right? Well, the way you normally do it is you go, okay, these two are neighbors, these two are neighbors, and this one's a neighbor. And then you go, okay, and then that one's a neighbor, and then you're done. But that's kind of boring because like they're right next to each other, so you just keep drawing straight lines. And since I already have to figure out how to like make an enemy walk this, I decided, all right, what I'm going to do is invert it, and then I'm going to use the Dijkstra algorithm to figure out the paths between rooms. And that's it. And then I just gave it some color so I can see what's going on, and there we have it. So this looks like it kind of works. Let's try another run. Maybe we get a crash. No, yeah, that's working. That's the path. Yep, there we go. Check it out. Okay, well, it's basically working. All right, so the trick is you look for a next lowest neighbor, and if you don't find any, but you keep track of all the ones that are 0. If you don't find any that are next lower, you just pick one that is no difference in the number. And then eventually it'll path to there. Yeah, and I do like the way the path turns out, because it's not just like it's not like picking a door here and going like that. I can pick a random place for the door. Like actually in this case, I think the door was probably here and it walked down that way, like that. Yeah, so this would make it a little more interesting, and also kind of tests out how they should go. Yeah, so probably it was like this. Yeah, so most likely this was the room, and then it went like this. Yeah, it's not bad. I think I might be overshooting it. But yeah, that just looks like it just went straight down. So then, like you say, I need to add in a little bit of randomness, right? So that maybe it gets here and I have it like do a hiccup where it walks off path for a few. But I think for a first cut, I'm just going to have it do just normal. And also make it not crash. But it's way more reliable. Yeah, and part of the reason why it seems to always do this kind of weird nipple on top down is because I just put the doors on the tops of all the rooms. They're just not the same position. So I'll have to like start randomly placing them. All right, everyone, ad is starting soon, but I am going to sign off. So you are free to watch the ad if you would like. And then I will see you all tomorrow. We've got this working more or less. It's very jank. I think I'm going to basically clean this up tomorrow at 4 p.m. And at 10 p.m., I'm going to try to have the character walk around in the room. And then if we can, we're going to get an enemy. And this will help because now I have like how the pathing should work.